久しぶりというか3日ぶりかな。これから勉強を始めます。今日は前回が終わったので、4つ目の Java プログラミング続きから、1週目は Welcome to the course。2週目からがメイン。まず1週目を行きましょう。
This is Duke University.
In wondering how to describe this course, the phrase, "I think to sort the people tremble," from Confucius, came to mind. But I then realized that Confucius did not write precisely these words, although each of the 6 adjacent pairs of words does appear in his sayings. We could generate that sentence using an algorithmic process related to predictive text, the process of Markov text generation.
That's fascinating. I was thinking of Shakespeare's Romeo and Juliet, where the phrase, "the earthquake, now Romeo must die," another phrase whose adjacent words are found together, though not the phrase itself. If we had 1,000 interesting phrases, we might want to search through them to sort them to find interesting ones more easily.
Great idea. What a coincidence that the phrase from Confucius and earthquake was from Romeo and Juliet. If we could filter through the phrases, this might be similar to the way my mail program separates spam from regular mail. Being able to process the phrases ordered by how many words they contain, or how readable they are, or how interesting they are, would be useful in understanding trends and patterns in random text, or even in the earthquakes Romeo was speaking of.
You 3 must have already participated in this course, Java Programming, Principles of Software Design, because the topics and ideas you've discussed are important components of the course. We use live and archived data of worldwide earthquakes to understand sorting and searching, as well as to learn about object-oriented concepts like inheritance, interfaces, and abstract classes.
That's right. We are part of the team that created the course with you, and we're very excited to bring you, our learners, this 4th course in our specialization. We use software design principles to illustrate Java programming, and we use Java programming to illustrate software design principles. This mutual reinforcement helps make the concepts understandable, as well as transferable to other problems and even other programming languages. So we're working to build your experience and expertise with Java.
I'm excited that we're able to illustrate principles of software design that are widely used in practice, like the open-close principles, as well as object-oriented concepts like ISA and HASA, that are foundations of software design and engineering in Java and other languages that are also object-oriented. The problems we've designed are engaging, doable, and have just the right amount of challenge.
We explain how to design your own classes using object-oriented concepts, but we also explain how to use classes and APIs that are part of the standard Java libraries. If you want to read files or URLs without using the edu.duke library, for example, you'll see lessons that explain how to do that, and you'll be able to study the classes in that library to see how we use the same concepts you'll be learning to design and implement the classes in the library.
This will be a great course. We'll get a glimpse into what we hope will be your continued study of Java after this course using other programming environments than BlueJ, though BlueJ is my favorite environment for those beginning to study Java programming. We hope you'll enjoy the lessons we've created. We've worked hard to get them ready. This has made us each a little hungry. So we're going to toast your future in the course and our work in having finished creating it with cookies and bubbly cider.
Hey, Robert, could you select the largest cookie? That can be yours.
Thank you.
And Drew, you select the largest cookie from those that are left. And then I'll select the largest cookie from those that are left. Susan, you get that one. Hey, look. They're in sorted order by how big they are. I think we used selection sort. Now, let's each get some bubbly cider.
For that, we'd have to use bubble sort.
Cheers.
なんか寸劇が。プログラミングリソース。コースプログラミングリソースはコース4にありますと。で、ブルージェイは今まで使ってるからそのまんま。ブルージェイ、ここが、デュークのプログラミングリソース。必要な時にダウンロードして使うってことで、よいしょ。こうやってくるんだ。的ね。ゲットリソース、これね、ポジティブリソースだな。サーチングブルージェイ。クローゼストクエイクス。スタートプログラム。ラボ20。これはデータか。XM でデータ入ってんのね。フィルタリングデータ、レビュー。アトムなんだな。これ RSS で本当にやってたことか。N グラムズって入ってくる。とりあえず次に終了として、行きましょう。Module Learning Outcome Resource. AskX Programming and Interface Module. In this module, we will introduce dataset containing details about AskX around the world. You will learn how to put this data into a program, search through the data, and filter the data based on design criteria. At the end of this module, you will be able to write programs that include multiple classes and array list of class types, and maximum values and array list. Use the filter interface to search through. Implement interface with method signatures and combine several filters together. フィルターとしてインターフェースです。Mark courses resources. In course 4 index, this website of programming resource contains page for each course in the Duke Japanese subject. The link above for this course is where you will go to download the custom version of the BlueJ implement. BlueJ はもうすでにダウンロードしてる。Find project resources such as example code from the lecture videos. Download images and data files for the programming exercise and see documentation for the custom classes developed for this course. あとスライドがある。今さっきダウンロードしたやつだね。ダウンロード、Educations。フルスタックスコース。ブーストラップ集。待って。とりあえず展開してみましょう。ディスタンスデモ。メインブロックのこれは関係ないから、Searching AskX Data Starter Program。この後もほっといて、Java がプログラムが入ってると。これも後で 15J でパッケージで入ってるから、後でやってみようと思ったりするのかな。じゃあ続き。
Hello, we're going to look at code and concepts to investigate real-time earthquake data. Real-time means that your program will be able to access data recorded seconds or minutes before your program is run. Your program will also be able to read a file of recorded data, which will make it easier to determine if the program is correct as you develop and test the code. These programs will illustrate how to design classes that use other classes, and eventually how interfaces, a new Java concept, are used. These programming ideas will be used to study searching and sorting, fundamental concepts in computer science and programming that help in understanding data and quickly accessing the data you want. You'll also see how to use APIs, or application programming interfaces, to parse and transform data formatted using industry standards. These programs will be the basis of an exciting set of projects, but will also be the basis of possible further explorations in software engineering and computer science. Our capstone project will use these same concepts. The second specialization in Java programming, designed by our friends from UCSD and available now on the Coursera platform, uses the same earthquake data as the focus of their first course. We hope you'll be intrigued and curious enough to explore these concepts and these data on your own. We recorded real-time earthquake data on November 11th, 2015, with the program you'll study in this lesson. We used the earthquake data to create a Google map whose URL you see here. This snapshot shows earthquakes of low magnitude in California in the United States. The key you see shows that a yellow star is an earthquake whose magnitude is less than 1.5. Quakes whose magnitude is less than 2.0 are typically considered micro-earthquakes. You can see that there are a lot of these in California. We can also use the data from this program to show quakes in all parts of the world. Here is a map showing quakes of greater magnitude in areas near Southeast Asia, Japan, and Indonesia. The map makes it easier to see clusters of quakes. We created these maps by transforming the real-time data into a CSV file, where CSV stands for comma-separated values. Data in this format can be loaded directly into a Google map. You'll see how to transform data and how to use it as you develop the Java programs in this lesson. The data is obtained from real-time data feeds from the United States Geological Survey website at earthquake.usgs.gov. The data downloads in an XML format, a standard widely used format for structured data. XML stands for Extensible Markup Language. JSON is another standard format that is increasingly used for transmitting and storing data as well. JSON stands for JavaScript Object Notation, though the format is widely used in all programming languages. These are widespread standards, but parsing data in these formats can be somewhat tricky or tedious. As you can see here, the latitude and longitude data are formatted between tags that specify a particular kind of data. All modern programming languages provide an API for parsing formatted data. But as part of this course, we will provide an API that hides some of the details to help make parsing the data more in line with our use of collections and iterables. The programs you use will be able to parse and transform the data into other formats. For example, we need a CSV format for creating a Google map. Other mapping services use CSV data as well. As you can see, the latitude and longitude are stored as simple values, separated by commas, from other data about an individual earthquake. Transforming data from XML format to CSV format is relatively straightforward because the parser creates a Java object that helps with the programming. Parsing and transforming data is a common application that helps with solving problems and interpreting data. The code to transform XML to CSV is shown here. Parsing is not always simple, so we have created an API to make it easier for you to write programs to process earthquake data. The API creates a collection of earthquake entry objects where quake entry here is a Java class. Here you can see an earthquake parser object being created to parse XML data. You'll be able to look at the parsing code if you want, which uses standard API to parse the XML. The API we've designed can use the data that comes from a file or a URL. This will facilitate testing the program on the same data stored in a file, or to use real-time data that might be different every time the program runs. Here you see the source of the data being specified as a URL. This is the real-time data feed from the USGS Quake data. The parser uses the data source, reads the XML, and returns an array list of Quake entry objects. Let's look briefly at what a Quake entry is. There are two classes you'll use, Quake entry and location. The Quake entry class holds the data that's relevant to an earthquake and that comes from the USGS XML feed. As you can see, there are 4 instance fields we'll use in understanding earthquake data. The field myLocation is a location object which will help as you write code to find where quakes are close to each other or to you. The magnitude of the earthquake is a measure of how strong or forceful it is. The depth of an earthquake determines how far underground or under the ocean a quake is located. And all quakes from the USGS feed have a description related to the location of the quake. Location is a separate class. We could have used double values to store the latitude and longitude directly, but you'll see why a separate class is useful later. One class often uses another, or contains another, as the Quake entry class contains a location object. The location object was adapted from the Android standard libraries. Android code is based on Java and is the software that runs more smartphones than any other software in the world. Phones typically can help you find directions because they know where you are based on GPS sensors. The Android location class is a robust and well-tested class you'll be able to use in your programs.
データベースのプログラムを扱いますけども、これは JS のじゃない。XML だよ。RSS だからね。relationships between class。クラスの関係についてか。
Hi. In this lesson, we're going to talk about a few concepts related to how classes are used together in object-oriented programming in general, and specifically when using Java and the earthquake programs and classes you'll see. The Quake entry class, created in quakeentry.java, encapsulates the basic characteristics of one earthquake: where the quake occurred, the quake's magnitude and depth, and a title for the quake. This makes Quake entry what's called a POJO, or plain old Java object. This means a Quake entry object is not much more than the characteristics of the earthquake. Creating a Quake entry object requires providing all of these characteristics. For example, it doesn't make sense to talk about an earthquake without knowing where it occurred or how strong it is. It's not possible to create a Quake entry object without supplying all the parameters to the constructor, which makes this different than what some consider a plain old Java object, or POJO. As we'll see, Quake entry objects are created when data for earthquakes is read and parsed. Creating a Quake entry object requires supplying all the information for a quake: the latitude, the longitude, the magnitude, the title, and the depth. A Quake entry object represents the data for an earthquake that has occurred somewhere in the world, so it's immutable and doesn't change once constructed. Accessing the state of a Quake entry object is done using getter methods, as you see here. GetLocation returns the location of a quake. GetDepth returns the depth of the quake, and so on. A Quake entry object also has a reasonable .toString method to help with printing information about an earthquake. An earthquake occurs at a specific location, and so we'll use a location class for that. Location classes have many uses outside of the Quake entry class we're studying here. Smartphones use locations, web browsers use locations, and many other applications do as well. We have a choice between creating a location class that's simple, that we could use and study for this course, or we could use an industrial strength class that would be tested and useful in other contexts. We've adopted the location class from the Android platform. This gives us the best of several options. We can be confident that the class is well tested, and the licensing of the source code allows us to use and adapt the code as we need to. We'll see more about this later. Location objects are created from a latitude and a longitude. These specify one location on Earth. Typically, these values might come from your phone, which get data from GPS satellites, or your web browser, which can determine location based on your IP address. The Android location class has a .distance_to method to determine the distance between any two locations A and B. This will allow you to find earthquakes close to where you live. This makes the location class more than a plain old Java object or POJO. It has state, the latitude and the longitude, but it also has behavior, a method to determine the distance between locations. Classes in Java can have both has-a and uses-a relationships. The earthquake parser class creates quake entry objects when data is read and parsed. This BlueJ class diagram shows how the parser uses quake entry objects by creating them. A quake entry object also creates a location object as seen in the diagram. The quake entry class creates a location object by passing the latitude and longitude to the location object. This creates a new location object using these data. The location object created is stored in instance field myLocation. When one class has a or contains another class, we call this a has-a relationship. The location class implements comparable. We'll discuss this at another lesson. As you can see in the BlueJ diagram, the earthquake client class also uses a location object. Locations are used to determine which earthquakes are closest to where you live or to where I live. We'll see this in a coding demo. The location.distance_to method helps in writing this code. A quake entry object is also used by the earthquake client class. For example, this allows client programs to find all quakes of high magnitude using the getMagnitude method of the quake entry class. Happy programming.
ラグセンシングの IP です。ああ、そうか。出てくるんだ。
Hello. In this lesson, we'll discuss how we are able to use the well-tested Android location class in our programs. The location.distance_to method has a comment that indicates what the method does. Reading documentation is an important part of creating programs. This method returns the distance in meters between two locations. We'll remember that the distance is in meters when writing code later. You can also see that the method uses the WGS84 ellipsoid standard. Adhering to standards is a good idea. It helps to ensure our code is robust, accepted in a large community, and is verifiable as being correct. The World Geodetic System, established from 1984, is used here. We should be glad that we can rely on this standard rather than trying to determine the distance between 2 points on a three-dimensional sphere-like ellipsoid that is the planet Earth. Let's work to understand the location class API. The location class we are using comes from the Android system. Android powers more smartphones and devices than any other operating system. You can read the documentation and understand the location API on the web, like many modern APIs. This API is really useful in developing the many location-aware applications that run under Android. To use the location class, you'll need to do several things. You'll want to read the documentation to see how to use the class and what the API says about using the class. You'll need to create location objects using the ideas you read about in the API. You'll also call methods like distance_to by adhering to what the API documentation says and by testing your code using the concepts from the API.
What are some of the reasons the user already use class like location? Of use standards, like geodetic standards. Standards. タンダードです。まあ、これ3つ全部その通りよね。
The Android location class is licensed for reuse. The location class uses an Apache 2.0 open source software license. You can read the details of what this license allows online. The documentation that comes with location.java from the Android system indicates which license is used. The Apache 2.0 license specifically allows for reuse of the code in the location class and for the code to be changed. This is great, since we've taken the code and made some modifications to it. Our adaptations removed the location class's dependencies so it is usable outside of the Android system. We still benefit from the robust testing and development of the class, so we're confident it will work. We have also adopted the same Apache license as you can see here. Because we've chosen the Apache 2.0 license, you can adapt the code and make changes too. It works as given in our examples, so you can simply use it without making changes if you want. This kind of shared community programming is a powerful tool in creating software.
まあ、オープンソースに使うよね。Location classification and license resource. アパッチとアパッチライセンス。ここね。ここが、Android Developers だから、ところに、ソースがあって、ライセンスが書いてある。Public Class Location。Extend Object Implements Passable。パーサラブルとは、パース可能ってこと？まあ、こといいんじゃないの？これ Java だけどやってることしたよね。パーサラブルは、まあ、とりあえず、Android だからそれを入れてるってぐらいに呼ばれていいのか。All が generated through Location Manager Identities to have a byte along with timestamps UTC。UTC なのね。Summary format in format degrees, format minutes, format seconds。Constant use specified formatting over latitude or longitude plus DDD, where D in degrees. Format minutes。これを使って、latitude, location。あ、で、means the bearing degrees is convert latitude, longitude, coordinate to string represent. Convert string coordinate. Describe contents. Distance between. これはスタティックで、つないで。Distance to location. どのぐらい距離があるか。Dump. Printer string. Equals. まあ、イコールは今日だね。Get bearing. Get elapsed real time. 基本的には Get latitude longitude がさあればいいぐらいで。has, is complete, is from ボックルケースので使えるようになってるんだ。セット、アティチュード、セット、ベアリング。セットアリス、セットロングチュー、セットモック。作るときにモックオブジェクトとして作ることができるっていうことは面白いよね。フォーマットディグリーズ、コンスタンツ。パブリックコンスタンツロケーション、ストリングプロバイダー。ロケーション。というわけで、いろいろできます。で、アパチュライセンスについて。メモ手を抜いて、日本語訳欲しいかな。手を抜いて、Google で、よし、これ来た。これが一番、日本語参考訳で一番いいところ。はい。うーん。こっちの方がいいのかな。あと、ウィキペディア。今はこっちの方が正しいのか。OSGN だから。日本語参考訳。アパッチライセンス 2.0。ここでいいの、ここでいいのね。まあ、結局、基本的にこれはライセンスなので定義が何かがあって、ポイントここ。で、商標とか付加しませんのが大事なのね。修正した場合は長期に散布できますけれども、基本的にライセンスとコピーとかできる。説明はこっちのウィキペディアによると、オープンソースライセンスの緩いライセンスだね。まあ、アパッチソフトウェアライセンス。ユーザーがその人に主要や修正、派生分の配布を制限しない。アパッチライセンス、同じライセンス提供する要求しないが、ユーザーがその人にアパッチライセンスの今度を使えるとして派生文言を入れる必要がある。 許可の停止要件。どっちを選ぶかの話だな。というわけで、ここまで終了。
Hi, we're going to use BlueJ to gain some experience with filtering and searching earthquake data. We'll start with the existing Earthquake Client class, which reads and prints quake data. We can use this class to print CSV data from either the live USGS data feed or from data we've recorded, so you can load it from a file on your computer rather than over the internet. Since the data is in CSV format, you could also copy and paste this output into a spreadsheet and look at it there. This could help you check and debug the code you'll write. This live coding lesson will help you build experience reading and searching quake data, which will use the same techniques and ideas to search any kind of data. You'll be able to create new ideas for filtering data so that you can search the quake data to find patterns of simply finding where quakes occur. You'll see code to filter quake data by the magnitude of a quake or by how far quakes are from a specific location. You'll also see that using live data can make it difficult to debug your code since the data may change. We've captured data you can use to help debug, and you can do that as well. Let's start the coding now. First thing we're going to do is just process the data using the create CSV method we've written. And we can either read data from a file, which is what we're going to do first, or we could read it from a link. So let's just go ahead and run create CSV. So I'm going to create an object and run the create CSV method, and you'll see it's going to run and it's going to find from our file, it's got 1,518 quakes, and it's got information about the quakes. So you could actually take that data and cut and paste it and put it into a spreadsheet because it is in CSV format. And then that would actually allow you to look at the data in another way and kind of decide if your program is working correctly. So we're not going to do that right now, but that's something you could do. So what we want to do now is go ahead and figure out what are the big quakes from that file. So we're going to write a method called big quakes, which essentially is starting out the same way that we just started out the other one. We're going to read in all of those earthquakes from our data file, and then we got to figure out what the big quakes are. So let's do that. So as you can see, what happens here in our code is we have this line here, array list, quake entry list. So what we're doing is we're reading from with our parser and putting all of the earthquakes that we're reading into an array list of type quake entries. So we can iterate over those, which is what I'm going to do now. So for quake entry, we'll just call it QE. So for each quake entry, we're going to have to ask a question and find out how big that quake was. So we'll have an if statement. And we'll have to get the magnitude of the quake. So QE is our quake that's in our array list. And so we'll use the method getMagnitude.
Get the magnitudeを取って。
And then we'll compare it. What I'm going to do is just ask if the quake is bigger than 5.0. I want to know all those quakes that are bigger than 5.0. And if it is, I'm going to print it out. So I'll just print the quake out. And let's compile that and see if it works. So it compiled, no syntax errors. We'll just go ahead and run it. So we're going to, again, create a new object. And this time we're going to run the method bigquakes. And let's see what the output is. Okay, so you can see all of these quakes here have magnitude greater than 5. Now, another way we could do this is we could write a filter for this, because what if we want to get big quakes and we want to do other things? So I'm going to, instead, I'm going to do this a different way. So I'm going to go up here, and I've already started this method up here. It's called filter by magnitude. And what I'm passing in are 2 parameters. I'm passing in an array list of our quake data, of quake entries, and I'm also passing in a number, which is the size. I want all quakes bigger than that number. And then what I've done is I'd like to create an array list of all such earthquakes. So I've created a new array list here called answer. And what I want to do is go through the quake data that we're passing in, that array list, and I want to figure out what are all those earthquakes bigger than magmin, which is our number that we're also passing in as a parameter. So we'll just add code here. So again, we're going to create a for loop for each quake entry from our parameter quake data. We're going to ask the same question. If QE, and we're going to use the get magnitude function. And here we're going to see if it's greater than our magmin, which is the parameter we're passing in, the number. And if it is, we want an array list of all such quakes. So if we find a match, we're going to add it to the array list answer. So answer dot add QE. And we'll just check and see if this compiles. And it does. Now, in order to use this new method we wrote, filter by magnitude, we'll come back down here to big quakes. And I'm just going to comment out this part that we wrote here, because we're going to do it a different way. This time we're going to actually use our method. So I'm just going to put a big comment around this. And instead, we're going to write, we're going to call the method we just wrote, and that filter will then return an array list of all of the quakes that have the large magnitude. So we're going to have to create an array list to receive the answer. So an array list of type quake entry. So I'm going to call this array list list big. These are just the big quakes. And that's going to equal where I'm going to call the method. So that method is called filter by magnitude. And we're going to have to pass it the array list of all the quakes, which is called list. And we're also going to have to pass it a number. So I'm just going to pass it 5.0. So that will give us an array list, and then what we'll have to do is once we get that array list, then we can just print out the big earthquakes. So I'll do that now. We'll create a for loop just to loop over that particular array list. So for each quake entry QE, that's in the list big array list. what we'll do is print these out. Okay, so let's see if this compiles, and it does. So we'll go ahead and run this. So we'll create our object, and we'll run big quakes, and there it goes. So again, we get all the quakes that are bigger than 5, and you can see that. Now notice, we're taking advantage of toString, which knows how to print out an earthquake. It prints it out in this nice format that's got the location, the magnitude, the depth, and the title. And so we're also taking advantage of using that toString. Just wanted to point that out.
Coding the closest quakes. 一番近いやつを探す。
Hi. Perhaps you'd like to know whether a specific location is a quake danger zone. In this coding demo, we'll describe how to find the closest 10 earthquakes to where you live, or to a city where a friend lives. We'll write code for a specific location, like New York City or Jakarta, Indonesia, but the code will work for any location. Our code will find the 10 closest quakes, but we'll be able to replace 10 with any number. You've solved a similar problem before. Find the minimal or maximal element in a list of elements. This is similar. We'll find the closest quake to a specific location. We'll then repeat the process, but first we'll remove the closest quake from the data set. Then the same algorithm will find the second closest quake. We'll need to remove the closest quake, but we don't want to change the list of quakes. So we'll need to make a copy to avoid removing quake data. And we'll use 10 and Jakarta, Indonesia in the demo, but you'll be able to find the 57 closest quakes to any city you choose. The 7-step process is implicit in what we're doing here. Can you find the closest quake to a specific location? You've seen this algorithm before, finding the minimal or maximal element in a list. We'll use the same steps here. We'll keep track of the index into an array list of the closest quake, the one with a minimal distance to Jakarta. And each time we examine a quake entry, we'll update the closest index value if we need to. In solving the problem with paper and pencil, we'd cross out the minimal closest quake entry after finding it, so that we could repeat the process and be sure we wouldn't find the same quake again. In programming, we'll remove the closest element to avoid finding it as we repeat the process of finding the closest quake. Let's write some code. As we look through the find closest quakes method here, we see that we've created an earthquake parser, an array list of quake entries that we fill with data using the parser. Then I've created a location variable named Jakarta, and I've used the latitude and longitude of Jakarta, Indonesia. I've called the getClosest method, which is the one that we're going to write during this lesson. I've passed it the list of data that I read from the parser, the location that I'm interested in, which is Jakarta, and a number 10 so that I can find the 10 closest earthquakes to Jakarta, Indonesia. The rest of the method here is based on printing out that data. If I run the program now by right-clicking and saying find closest quakes, we can see that data was read for 1,584 earthquakes from the USGS source, but none were found, and that's because I haven't yet written the method that we're going to write now. So let's look at that method. The method we're going to write is getClosest. We can see in getClosest that it has 3 parameters. An array list of quake data, that's the source of the data about earthquakes that we're going to use. The current location, that in our demo is Jakarta, but could be any variable that you pass, and how many, which is 10. I'm going to write the code that you've seen before just to find the single closest entry. We've done that before, and we did that by tracking the minimal index. So I'm going to have a variable named minIndex, which I initialized to 0. That's the location of the closest earthquake to where I am. And then I'm going to loop over all the other data by starting at 1, going up to the parameter quake data. I will use its size. And I'm going to look at each one of those entries.
サイズで見ると、
by
current
obtaining the quake data from the array list using the .get method. And then I'm going to see if the current quake distance
これだけのロケーションのあれが使えたことか。
location, which is Jakarta. So this is current, the Jakarta reference. So I've used current here, which is not a good one. So we'll just call this quake. If quake is close to current, and if that's less than the distance from my minimal index, which is quake data.get min index. I'm working hard here to write this. Dot distance to current. That's a long list to fit on that line, so I'm going to break the line to make it easier to read. If the distance from the current quake here that I've read, quake, if the distance from that to Jakarta is less than the distance from the smallest location to Jakarta, then I need to remember a new minimal distance. And so I will reset the distance, the minimal index variable to k. When I'm done, I need to make sure that I store in my return array the location that's closest to Jakarta, which I get from saying quake data .get min index. Let's see if this code compiles. There is no distance to method. That's because I've forgotten the name of the method, so I will use the handy control space, which tells me that the names of all the different functions that I can use on a location variable. And we can see here that that is the quake entry class, and I've made the canonical mistake of forgetting that I need the location variable. Not just the current quake, but I need the quake location. So I will set location to quake.getLocation, and then I will use loc.distance to and get location.distance to. That's a mouthful, so I'll go over it to make sure once it's compiled. The program has compiled, and I will now run through it very quickly to make sure we're all on the same page. My minimal index will remember where in the array list quake data my closest location is. As I loop over all the data, I get the quake entry stored in variable quake. I use quake.getLocation to get the location of the current one I'm iterating over. And then I'm comparing the distance from that location, which is the one I'm iterating over in this loop. I compare it to the closest quake I've seen so far. That's what min index is, the closest quake I've seen so far. And I do that by asking if this distance is less than the distance to current, which is Jakarta, then I will remember and reset min index. If I run this program by coming out here, right-clicking, creating a new object, and then invoking the find closest quake, I will see that the closest quake found is 223 kilometers from Jakarta, and this is where it is. It found one. If I want to find the 10 closest quakes, I'll simply need to take this loop that I've done here and put that in another loop that iterates how many times. I can do that simply by putting a for loop around this. Let me make sure that that is down here. And taking all this code and indenting it. Let me just make clear what I've done. This is the code I'd already tested that loops through all the arrays, quake entry objects, finds the smallest one, and adds it to the variable I'm returning. If I repeat this over and over again, I'll find the closest quake, then the next closest quake, and then the next closest quake. The only problem is, once I found the closest quake, I'll keep finding it over and over again. We can see this by running the program, find the closest quakes, and we see we found the same one over and over again. Not surprising, we found 10, but we kept finding the closest one. That's a simple thing to fix. After we find it, we simply remove it from quake data. So our array lists have a remove element, and I will simply remove the element after I get it. So quake data.remove min index. After I've obtained the closest quake, I'll remove it so I never find it again. Compile that program, create a new closest quake object, and find the closest 10 quakes. I can see here I found one quake that's 223 kilometers away, and the 10th closest quake, which is more than 2,000 kilometers away. I'm reasonably confident my program works correctly. I'd like to verify that by running it through some real data. The only problem I have is that right now, after finding the 10 closest quakes, I've removed them from quake data. That would be a simple fix to make: create a copy of quake data and use that copy. To show you how that would work, I'd simply say create a quake entry named copy, make a new array list, and construct that from quake data. Now simply use copy everywhere in my code instead of using quake data, so that I know I'm not modifying my parameter. Instead of quake data.size, I'll use copy.size. Instead of quake data.get, that one's fine. Down here, I'll use copy, and here I'll use copy. When I compile that program, there are no syntax errors. I want to make sure I'm not using quake data anywhere. I'm looking through my code. I've used copy, quake data. I need copy there. And now I'm set to go. One last run. Find the closest, and there they are. I found 10 closest quakes to Jakarta, Indonesia. Let me just remind you of what we did there. I took my standard code for finding the closest quake to one that was specified by the parameter current. And once I tested that and found one, I took that code and added this loop around it so that I could repeat it this many times. How many? I then realized I was modifying my parameter, and so I made a copy. Happy programming. Don't get too close to an earthquake. Hi. You've seen code and concepts for developing and using classes to search earthquake data. Often, classes use other classes with has-a and uses-a relationships. This means storing objects in instance variables or as local variables in methods. These are standard object-oriented design concepts that apply across all object-oriented languages, not just Java. In our examples, we processed streaming data that might change each time the program runs. We treated parsing as a black box, relying on Java libraries to parse XML formatted data. We developed the XML parser, relying on standard Java APIs. And you developed Earthquake code, relying on APIs for standard Java libraries, as well as those we provided. To help with debugging, we also used data stored locally, rather than streamed. This allowed for smaller, repeatable debugging runs. We touched briefly on software licensing, an important part of software development. We used the location.java class from the Android platform. This helped in knowing that the code was robust and well tested. The location class is licensed with an Apache 2.0 license, a standard open source software license. This license allows us to modify the code to suit our needs outside of the Android platform. We could license the modified code using other licenses, but we chose the Apache 2.0 license as well. In other courses we've developed, we used the Apache Commons CSV class to parse comma-separated value files. This code is also licensed using the Apache 2.0 license, although we did not modify the CSV library. As you processed Quake data, you practiced programming and design skills. The programs you saw and wrote include those for searching for Quake data that satisfies properties related to magnitude and location. In searching, filtering data entailed returning an array list of Quake entry objects that satisfied criteria such as being close to where you live. In searching for the closest 10 or 20 quakes, rather than all those within 1,000 kilometers, we used different but similar techniques. In particular, we made a copy of the data being searched, since the code we wrote modified the data in the process of searching. These concepts and skills are a foundation for further work in searching and sorting data. Happy programming!
さて、Programming Exercise Searching Earthquake Data。さて、CD、リソースリンク開けといて、For the following assignments, you will start with its first provided using most and modifying only a few of them, and create a new class. The class provides the class location from the Android bottom and the device for this course. A data class represents a video graphic location. One of the constructors was planned to be pseudo-knowledge, and one of the public methods is distance to. The class frequent from the lesson which has constructor had required latitude, longitude, magnitude, title, and depth. There are several get methods and two sorting methods. The class asks Quake parser from the lesson, which has the read method with one string parameter to represent an economic ask Quake data returns and a list of Quake derivatives. The class asks Quake which has been started for you and creates an ask Quake parser to read in a Quake data file. Creating an array list of Quake entries, you can test the program with the method create CSV to store an array list of the year's Quake data and print the CSV file. You will complete the method of that filter magnitude understand in that class and assign method to it. The class closest Quake which has been searched to you find 10 quakes to persecute location. You will complete this method. You can run your program on your on C live data. But in order to make sure your program is correct, we recommend your program on small file we have created that only 0 lines as Quake data. There is no contains Quake or small atom, and its contents printed as Quake entries. このようにデータがなっていると。In this material computer vision user as Quake data toマグニチュードフィルターとディスタンスフィルターを作る。まずは、Git ブランチのメイク。はい。デューク。Java。グリーン。ここに、 えーっと、一周目の一周フィルタリングデータと、プログラミングサーチングアスペクトデータ。これは違う。ブレイク01%マイナスのアースク X とこう。アースク X。そして、ここに、このサーチングウェイズ。このデータを使ったこれを、うん。こうするという、ここに、これをコピーして、リネームして、サイズサーチと、これで、コード内。デュークジャーのエクササイズ1はサンチングと。入った。で、それで見て、アースクエイか、プロジェストクエイクス。順番に見てみよう。これは飲まないんだよな。クエイクエントリー。ゲットロクス、ゲットマグニチュード、ゲットヒン、ゲットデプス。で、あとはコンピアト。まあ、ポジョだから、これはそのまま。アースクエイクパース。本当じゃないですか。これはこのまま読んでいけばいい。これはあんまり、OK でしょ。これがパッチの、入ってると。で、クローゼストクエイクス。これこっちに置きたい、入れときたいな。いや。いいのか。メートルでいいのね。まあ、読み出てこれ組めたタイムになってくるか。アースペクレイン。スタブでその理想的に作れる。クエイクエントリー。アレリスクエイクエントリーリストマックス。スタンプ CSV。 Big quiz close to me. Create GSP. Okay. Toりあえず、コンパイル。これで、実行してみると、全部で25個のファイルが CSV でできると。OK です。では、順番に。違うよ。違う兄弟だよ。だって、filter bring my magnitude and distance. First method by filter by magnitude. フィルターバイマグニチュードが、アースクエイククライアント。ここはもう作るだけだよね。アースクエイククライアント。で、これビッグクエイクでそういうのをやって、プリンタースケさんここが小さいのを作って、経験でここをやるだけだな。さっきのやっと。おー。いや、そうじゃない。ビッグクエイクリスのここのリストサイズ。こういうところは今のうちにやっといた方が、楽になるはず。待って。アンサーを見るんだから、こうやって、 クエク、QE、コロンの類じゃないって。セミコロンのLN。ここをコピーして、そこの3が、こうなる。で、リスト、ビッグクリックしてる理由。クエクとイコール、フィルター、マグニチュード。マグニチュードのベストコン。プリントクリックしていいや。AX のビッグエスト。ファイルで、これでエラーはなし。これビッグクエイクを実行すると、あれ ?1918 クエイクス。ストリングスをスコール、こうやって、こういう風にするわけね。で、やっちゃいましょう。このまま簡単に、ウェイクで、QE コロン、これの微妙なドローがいるように。if, さっきのあれでやったら、コントロールスペースで、マグニチュード。これよ。あ、さあ、に、うわぁ、これでできねえのか。そうなる。ビッグブレイクが25の26マイナス11、24。できると。ライトのフィルターするもんだったの。これでピンが飛ぶ。ここまででマグニチュードができたから、今度は距離の方で測るやつ。Write the method to fix the distance from that has already been started. This method has three parameters. One, a list of type double named objects. The location named. This method should return a list of type all the asks from the data that are less than this maximum the location from note that we have already created a list named unsupervised. で、この次、ビッグクエリーのロケーションfromそして、modify this to close to mean that does normal public or filter by distance to print. So that asks the expression. Damage. For each asks to print distance. But it use get to him. Don't do this machine. ビルドソフトウェアは close to me. ソースもこれをやっといて、クローズソース。 こういうふうに書いておくと後が楽よね。えーと、アレイリストですね。イコール、view type by distance from。リストコロンは、1000km。メーター単位であるから、1000の123。うん。今、もうすぐ6時。とりあえず、プリントクエクスこれでいいや。クエクス。これでとりあえず、コンパイルはできる。セミコロンとして、消して、どこで選んでた？あ、N じゃない、M だ。 86x。まあ、ここは当然。さあ、中身は実装すればいい。中身のクセ層がここだな。こう。QE。データ。ここで、リンゴってなんて言うんだっけ。これ、これか。if, ディスタンス。ディスタが、ウィークにゲットロケーションその平気か。地震が起こった場所との距離が、これで、1000キロダウン。あり。えーっと、コンパイル。次は、ロースト。双葉ですね、アッターピントのように。1000km から1、2、3、4、5、6。プリントケースダメか。 何か0を追加しておいて、お、上く、えどり、く、えセミコロあるともう一回クロースと18。7ってなんか18になってるな。えーと、どこか違う？かけて、1000メートル単位でもになるはずだから、実行してみると、X。じゃあ、スモールじゃなくて、 これでコンパイル。で、それをやるとして、それはダメだから、ブリッジボール。ロードディスタンス。ディストイコール CT。これでどうだ。うん。分かった。消えちゃった。ウールにしよう。コンパイル。アスクエクエアンの多い。つもりしないとわからん。うん。これだいたいいいんだけど、メートルだからキロメートル単位に直さなきゃ。終わり。で、まあ、何が出るけどね。これでコンパイ。うんうん。こうやって、やると、2キロメートルシアバンツ、カリフォルニア。リアクスイルが見える。OK。ディスタンスも。うん。In this system, you mean earthquake by their depths. Finding those earthquakes whose depth is between minimum and the maximum value. What minimum of what in the depth of the earthquake means see the information. まあ、これは震源の深さを見てってことですね。Especially, what is the UV methods of blankets? Ask critical class, what methods to filter by depth of the three parameters? A list of quake entry name to quake data, table name, in the table name of next steps. Write the points quicks by depths. まずは一覧を表示するデプスを作る。と思ったけど、一回閉じて、次、コミットしましょう。Java の方で、夫の Java。そうと。そして、もう一回。保存してからやると、なんていうか、安心感あるかね。うん。フルタリングバイデブス。クエイクスオブデブス。 れだけ書いておけばいいだけよね。パブリックボイドのこれはここ、2つコピー。分かってるところは、コピー。ペースト。かな。ん線だな。うん。なんとなくこれがずれてるな。 まあ、とりあえずこれで一覧が出ないことにしょうがない。これで今作ったクレイクステップスで20を表する。あとと。えーと。これ X でいいや。X のフィルターバイテープス。リスト。うん。まあ、これは、下になので上に書いた方がいいって。これをどうか形するかって意外と気になるところよね。コードを一回ここを削除して。はい。で、イン、ちがいいのかな。やっぱ仕組み書きながね。ない方がマックスに出せるよね。うーん。 絶対決めるならこうか。オプション、クリアと。さあ、やってこれ簡単なんだから。ここから。これで OK。えっと、1万が入んないのか。でもこっちも入んないな。だからここは、いや、1万は入れなくてもいいの。ちょっと待って。フィルター by Midest Analyst Example Available. This data analyst type quickly as column. Mean depth and max depth excludes. 両方とも、いや、入らない。ひどいんだけど。だから、イコールはなし。そうすると、うん、could you try simple control camel? 今度いつ見ますかね。 OK。ここまで OK して、X。次かと。Assignment 3. Filter by phrase in title. In summary, you will filter the aspects by a phrase in the given folder aspects in 3 ways. And those aspects to start with the phrase, end with the phrase, or just have the person on the title. Quakes by phrase. どうすんの？それで、でも、僕は何も持ってないよ、だから。はい、はい。フレーズ。filter by phrase and put all the description phrases. まあいいでしょう。いつけ、filter by で、method quakes by phrase. filter by phrase. list. まあ いや、まあ、こういうのは、して、フィルターバイプレイス。フィルターバイプレイスと、フィルターバイエクテータ、リング。ここはまあ、消して、ストリングレーツ。It was by first balance array list type containing correct data signal pair. ペアだとインディケートか。インディケート。イントクレイクスじゃないんだな。さあ、これで実行ができる。クエイクスバイプレイスって、カリフォルニアと。あ、25は以下から入れてた。えそれ、for example, you will add a new method to one class, the earthquake class client に、write a new method created by plate that has three parameters, an array list of type quake entry named quake data, a string named where that indicates where such title and has one of three values start, end, and any, and a string name phrase indicating the phrase to search for in the title ask. The title of each quake can be obtained through the get if. The filter phrase method should return an array list of type quake entry or all else quakes. Okay, data first titles have the given phrase found the location there. Startのフレーズ must start the title. End means the phrase must end the title. And any means that phrase something anywhere in the title. つまり、インデックス部を使って、filter by phrases。インテジャー x イコール QET get のインデックスオブ W where if インディケート文字列言ってるだからこうでなくて、ANSW QE これでエラーに見つかっちゃいけない。ただし、Yes。これで、例えば、裏スタートで探すなら、例えば、スタートで実際のデータで、よし、わからん。例えば、エクスプロ。 こうやって、これで検索した場合、初エクスポージョンが出たから、次。あ、インフレやっとけそうだな。ボール9位。うん。どうだ。エラー。これでうまくいったらラッキーと。ゼロになった。やっぱしなぁ。 長さが関係監督入れないとダメってことね。つまり、この場合カリフォルニア分の文字数を引かないといけないから、レングス引く。これは、レングス。これどうだ？マイナス1じゃないかな。この4つが見つかればいい。これは、これで4つ出てるから OK。最後。ちゃんとやるからにはビレッジとか何のついてもやっておかないと意味ないよね。ファイル、じゃあ、ね、まあ、コミュニしたからですね、じゃあ、これで OK かな。で、別にこれ1個だけだよっていうことで。じゃあ、UUAR。境界値っていうのは大事だから、0でスタートで見つかった場合、これプラスが出てくる。当然、カリフォルニアエミ まあ、そうだね。そして、finding the closest earthquake to a location. Assignment: Finding the closest earthquakes to a location. Closest quakes class. さて、次に、今のこっちはうまくいったから、closest quakes quake entry。アサインメントポンの前に、サイズ、サーチングス。よし。これユーズフォンをスキップするのでいいのかな。ラスト。かな。まだ2つ残ってる。どうしよう。もう7時だからで2時間過ぎてるから、今日はここまでにして、いや、ここまでにしましょう。自分でやってよ。
どうやってやる ?YouTube?
Gmail 見て。
うん。
Gmail。